Right. Good evening, everyone. Welcome back to tonight's session. We're going to continue tonight's session with we'll talk about data structures in Python. So like I said, just to recap, the data structure is how we actually organize our code. The first data structure we've talked about is lists. Right. So and remember, it's very similar to string. So I could say names equals to I think I use Ola, Lu, that's it today. I should use Sunday. This is a list, so as you can see, it has same data type. So the same data type here is the string. However, in Python, because Python is a dynamic language, we can actually use number. We can use other numbers like 10. And once I put my names like this, it just says a list. But supposing I delete the third, it's going to tell me it's a list of string, str. So list of string. So, and there are multiple functionality we can do. For instance, we can actually uppercase every name. Right now we have it. If I print my name, right, and I try to uppercase my name, so names dots. Now we did loop last time, right? So one way we can actually uppercase this is there's no inbuilt function, because remember it can be 1, 2, 3, 4, 5, 6, and there's no way you can actually uppercase a number. However, one way you can look about it is loop over this loop. So this is the loop, right? Then for each of them, we are going to maybe change everything to uppercase. So to do that, so we use the for loop. So we're going to use the for loop in Python. Right. I could say, remember the indexing? So now let me make it easy for you. So I want to loop over this, and I'm going to print the uppercase version of each one. Then later I'm going to show you how I can actually append it to this. Okay, now so once we loop over, so we're going through the names. So we're starting from the first name. So when you see for name in name, so we're starting from each name in the names list. Right, so I want to print out name, which is this variable dot upper. So once I print this out, so we're going to see everything listed out. So everything's going to be in uppercase. So I'm just going to bring out my terminal, and I'm just going to do Python multiply. You can see everything is being uppercase because of this function. So we're calling the uppercase to it. And I think we make use of the append method last week. So the append is we're going to add to the back of the array. Sorry, I said array, sorry, list. Sometimes you can actually make it interchangeable. In Python, it's called a list. Now, if I want to append, I could just say names dot append name dot upper. Now, you may be wondering, how would this work? So we have this list, we have this defined list that we're going to go through over 3 times. Then I think names.append name.upper. What's going to happen? Are we going to, once I append the next one, so I can just use a comment, and I have Ola. So you may be wondering what's going to happen. So maybe we're going to have Ola first, then later on, it's going to see this list as a for list. So let me just execute it. So it's going to see it as a, because I keep appending to the new list, this is going to be an infinite loop. Because remember, the names, we are updating the name in real time. So it's not going to end. I'm not going to stop it here. You can see it's not going to end because I keep appending to the name. So the name is now going to end up being infinite. So is that the next time when you reach here, it says that there's another names again. the next time it gets to here, it's going to see there's another name. It's going to keep repeating just like an infinite loop. So in order to prevent issues like that, one way is we can actually replace this, or we can actually create a new array called names. Okay. So it's an empty, so I cannot say names uppercase dot append name dot upper. So this is going to give us a new list, right? And I click on enter. I say I'm not printing thousands white on the edition. Print name uppercase list. So I see the first list is this one, which is not uppercase. The second one is the uppercase one. Now, what if we ask that we need to actually modify that list? What can we do to in that not here in that case? So we can actually replace it. So rather than appending, which means we keep adding and then of course an infinite loop, what you're going to do is, so you're going to have a counter, and I'm going to show you another way we can do this counter. We can say count or index equals to 0. Remember, I will start from 0. I could say names of index equals to name dot to dot upper. And I can print names. So let's write that. As you can see. So why do I have this error? Why is everything in change to 2020? The thing is, I failed to increment my index. For short, I could make it so which is short for index equals to index plus 1. As you can see, we have the sentence. So this is one way you can actually modify the existing array. Now, there are other functions that can give us the index without us manually creating our index. And for that, so there's a function called enumerate. We'll pass in a iterable. So our array names is an iterable. So now you can do something similar. So I'm going to comment this out. And I'm just going to do. So this name is a tuple. So we're going to talk about tuple next. So what it tells you is it has the index, also as the name. As you can see, the index is an integer, just like our index over here is also an integer. And this index now, okay, let me just before you get confused. So this index is not this index. Now, that comes to scoping. We're going to learn more about it when we learn about functions tonight. So this index is more like in the global scope, right? But this one, this index is local to only this for loop. So global in the sense that everyone can actually make use of the index. So for instance, if I change this to IDX, right? And I try to print IDX here. No, so let me just pass. Let me just use the keyword pass. So if I try to use IDX here, as you can see, it is unbound. But this, if I try to use index here, it's just telling that it is the number 0. So this is global, meaning anyone can actually access it. This is local, meaning that it's just for this for loop. But because of this ID is not really smart, that's why it's telling, that's why you can actually access it. But if it's other programming language to have thrown an error that it doesn't recognize IDX because you're trying to access something out of scope. I'm trying to look for a real world example so that I can explain this scoping later better. when we talk about method, I would explain more in the scope. But the sense that the scope is like maybe there's something that maybe your family call you a particular name or your friends call you your nickname, but there's a name that you actually use outside, maybe which is your legal name. So scope is okay. This I'm going to only answer this particular name when I'm within this set of people, when I'm within this scope. However, when I'm outside, I'm going to be using index. Like, but they are not the same thing, right? They are not the same thing. This is only for this variable. This IDX is only for this is only for this for loop. So for loop is a scope pointer. So scope is anything that has a colon. For loop, while loop, method functions, they are all scoped, right? So anywhere you see a colon, just know that anything within this variable, maybe I have another one called index again, right? Well, because of the way Python works, it can actually access this index. Remember, I can actually access this index in here. However, this IDX cannot be accessed here, cannot be accessed in these names because of scoping. So I'll look for a real life example. Anyway, I'm just going to delete this index. So we're going to do something similar. You can see we have our name. So this index is similar to the count, similar to the index we created initially. I'm just going to names colon IDX equals to name dot upper. But this time my name is lower. So, and the beauty of this one, I'm going to remove the pass now. So, and the beauty of this one is I don't need to increment my IDX. This enumerator actually does it for me. As you can see, it starts from index 0, or it starts equals to 0, and it's increment everything for me. My index is 2, IDX is 2. So on other programming language, I shouldn't be able to actually access it as long as it is unbound. But the way Python works, it actually makes me access it. But generally, this is the scope. This shouldn't be available outside of the scope. But you can see, let me print names. Print that my names. So everything is now in the lowercase form, and I do not need to increment my IDX. So this is another important function, and actually work as it is a class. So we're going to talk about class tonight. So this is index. There's other functionality called list unpacking. So I'm going to delete this. So we have the list unpacking. The idea of unpacking. So, and the idea of unpacking is actually for data structures. For instance, I think you can unpack strings, you can unpack lists, tuple, and the likes. Now, so when I did this is the concept of unpacking, because if I just leave I here, so it's going to tell you that I is a tuple, an int, comma, string, and I went for that to do IDX and name. So I have unpacked it. If I did not unpack it, I would have to access it using a full stop or a square bracket. So now we have names, Ola, Olu, Tunde. So the idea of unpacking is that maybe I want to collect Ola only. So I could say Ola, comma, names equals to this. And when you're unpacking, you need to have same number of elements if you don't use the star. So if I print out Ola, I unpack Ola. So Ola is the first element. And if I print out Ola, I have Ola here. And if I change to first name, it's also first name. Right. So rather than using the array index method, right, I can simply unpack it. And the many names is going to be stored in this name. So this names is going to stop the meaning. So it's going to have only Olu and Tunde because I have, it's like you removing something from a box. That's the concept of unpacking. So this is unpacking, and I simply packed the meaning values of the array inside the names. So Ola is with, I've collected Ola. Now I'll remove Ola from the names array, and I've packed it inside the first name. However, the remaining one is now stored in these names. So if I print out names, I should see the square bracket Olu, comma Tunde. As you can see, Olu, comma Tunde. So, and it's very useful. Though you may not really use all this I'm teaching you in automation, but it's just easy once so that you can pass your interview in case you have a Python automation interview. So,
Sorry, I did. Sorry,
mm,
when you say, I think it's a split of tongue. If you're mentioning Harry, I'm sure you wanted to say Lee. Uh,
I keep
since
saying
you
what?
said no Harry, I think you were
Oh,
mentioning Harry,
I keep
Harry of Ola.
oh my
You
god.
keep mentioning, yeah. So me, I want to know. I find there's no Harry in Python, right? For you to
There's
be
Ari in
mentioning
Python.
Harry, what?
There's
There's Harry in
Ari in
Python.
Python. Yeah, yeah.
Okay, okay. I thought you don't use Harry. That you said you only use list instead of Harry.
No, there's Ari in Python. Sorry. I want to try to get the imports from, I think you
Okay,
have data structure. And there's Ari in Python anyway.
okay. Is it the same thing as list?
No. So the difference between an array and a
Okay,
list is like I said, this is a fixed size. Sorry, this is dynamic, meaning that I can actually add any values. I can actually append infinite number, and I did not set the size. But if we are working with compiled language like C++, C Sharp, Java, there's an array. I don't have, I would have showed you, but I don't know. I'm going to remember how
there's
to
actually
bring
array. There's actually array in
this.
Ruby. Anything like this is array. So I'm just confused when you mentioned the other time that it is list. There's no array
Yeah, it's a
in
list, not
Python.
an
So I
array.
wanted
As you
to
can see, it is
sure.
list. No, there's array.
Okay,
But what we're working
okay,
with right
okay.
now is a list. Majority of the time, you're always going to work with lists. So you use array. Let's write it down. So array is used, but I don't think it's part of the standard Python type. When
Okay.
so, but in Python, it's something called a tuple. So rather than an array, we tend to use a tuple. So the same thing. Let me just introduce tuple now. Let
Okay.
me just
Okay.
call it names
Okay.
tuple equals to. But this time I that's use a circle bracket, curly bracket. Then I can use Ola, Olu, Tunde. So this and this is the array, meaning that I can't actually append. So if I do names tuple dot append, so there is no really append here. However, in the names dot, I can actually append. I can actually modify the list. So this is name tuple. As you can see, it is just the tuple of Ola, Olu, and I can't modify it. So this is what we use instead of an array. So there's no really array in Python, and that doesn't mean that I can't add another number. So I can add number 10, right? So, but you can say it's still going to accept it. But in other program language, for instance, if you are moving to C sharp, you can't do this. I'm not on my Windows system because of it. That's an issue. That's why. So as me, I would have showed you how C sharp actually deal with array or Java, right? But right now, the closest thing to an array with like based on Python built-in types is actually a tuple, which is just a fixed list that you can't change. So I hope I answered your question. But
Yes,
generally
thank you.
speaking, even when you're working with C sharp Java, you're more likely to work with an array compared to even a list. But Python has a list. I say Python has a list, C sharp has a list. Um, Java has array list. Sometimes learning too much programming language is not good. So let me just continue back on my profile, come back to this. And so the concept of unpacking is you just want to take, just like if you have something in a bag, you take it out, you take one of the item out, right? You put it somewhere. That item is not part of it again. Or maybe you have a pack of, maybe you have a dozen of biscuits. You remove one biscuit. You can't say it's in a dozen of biscuits anymore. You are going to give it a totally different, maybe 11 biscuits this time around, rather than saying a dozen, which is 12 biscuits. So that's kind of the concept of unpacking, but it can still be in the same carton. So it can still be in the same names, but you've removed it. And this asterisk shows that. So you want to remove Olu, right? I can simply put Olu here, or I can call it second name, right? So this is my second name. If I print out second name, I am going to see Olu. So remember, we go sequentially. And since I only have 3 names, I don't need to unpack everything into the array. I can simply put last name. And I'm going to see everything singularly. So this is one way you can actually unpack your array. So this is very important when you're dealing with array. You just simply want to maybe take the first value or take the last value. I don't want to use indexed. Generally, if anything that these are going to come from mind, take the first value. The first thing I'm going to come to my mind, I'm just going to try to use index or slicing, right? Because it's actually like this indexing and slicing is what's the keyword? So is general to almost all languages, like Kotlin, like Java, like C Sharp. They make use of slicing, but Java doesn't make use of it. Most modern languages make use of slicing, where you just have that bracket colon, maybe 0, something like this. So indexing, majority of languages make use of this, including Java. But slicing, we have up onto column, maybe 1. I don't think Java does this, at least based on my experience, unless they've updated it. So back to Python. So this is slicing. Sorry, this is how you can unpack a list. So you just want to take, maybe, as you can see, we have 3 items. We have 3 items. So what happens when we have the 4th item? And I try to print my 4th item. You can say I have an error because the item we have here doesn't equal to the item we have here. And similarly, if I only have 2 elements, or my list has 3 items, yes, we're going to have an error. It's telling us that maybe we should need to pack it into an array, or we need to just remove all the elements. As you can see, we have an error, but the error is not really descriptive. So anytime we're trying to unpack an element, if we only want maybe some out of the elements, then we just need to pack the remaining ones. Like, you know what, we're not using them inside this, or we should just exhaust everything, meaning that what should be on the left-hand side should be same as what we have on the right-hand side. And in our case, we can use the last name instead. Right, so once I run mine, so you don't have this in another program language apart from Python. That's the sweet part. So that's one about Python, is extremely flexible. There are multiple ways of doing something. I may never have told you some way. Maybe it skipped my mind, but there are multiple ways you can do it. As you can see, we can use slicing to actually achieve the same thing, right? We can use maybe indexing. Well, I can also use packing and unpacking. And can actually do, maybe we have the names. Let me just change these 2 names. So okay, it doesn't have. Anyway. So this is the names. And what's the last concept I want to talk about? Okay, now this is the most important. This is going to be that's going to be so more important part. It's list. The next one is, this took me a while to get actually when I was learning programming. So I'm going to talk about map, filter, and list comprehension. Now, talk about map, filter, and list comprehension. Remember when I said that I want to modify everything to an uppercase, right? And return a new array that we started with a empty array, names uppercase, like that. So we can actually do that in one go using the map. So we use map. The map is used when we want to modify the list, right? And similarly, filter is used when we want to just filter or name those maybe want to make the list actually what's in the keyboard. So we want to make the lists be a certain form. For instance, if we want to filter everything that doesn't start with O, right? We could use the filter function. So we just to filter based on certain condition. So I think we can only have one condition at a time with filter, but we can actually map them together. Then we use list comprehension. So list comprehension is actually use. We can use it for mapping. We can use it for filter. It can be for both map filter at the same time. And this is the Pythonic way of writing your code. So let's start with the mapping. So let's say we want to go back to this uppercase all our name. So I could say, let us go to results equals to map. So the map is a function, right? So you can see this is a map. It takes in an function and an attribute. So now we're going to talk about lambda expression. So this is a lambda expression. So in Python, a lambda expression is a nameless expression. So meaning that a expression without any name or a method without a name. So that's what we call a lambda expression. So and let me explain what this does. This trait concept actually adds to wrap your around. So this is we start a lambda expression by saying lambda, then x. So we're going to loop over the names. So we're going for each name, we'll do x, then we'll do x dot upper. So that's how we use the lambda expression. So and we can also pass in a normal function. So but the upper is already a function. I say uppercase. We'll talk about function later on. Uppercase. We'll take a name. So I'm going to take a name, then colon. So I'll say return name dot upper. So it's not coming up. And I'm going to change this to give it a type of str to know it's a string. Then rather than using a lambda expression, I could start with uppercase. So I don't need to call the uppercase method. We're going to talk about calling method later. But this is the map function. And I can have my result and I can print my results. So what it does, similar to what I wrote initially, was a lambda. So let me just run this one for you. So that's true. So we return a map object. So I could say dot print our map, we're going to use, we can either use a for loop or we can convert it to a list, because the map object is, well, wasn't the keyword. So the map object is a class and doesn't have the print method. They've not included the print method yet, so I can convert it to a list. If I print it, you can see we have everything in uppercase. So two key things you need to take away with this map is, number one, it takes in a function and an iterable. So iterable is like a list. So that's the first one. Then another one again is that you can't print it. So if you print it, you get a map object and the memory address. So you need to convert it. Or you use the for loop method to loop over each of the map sequentially. Now let's talk about the lambda expression. So let's talk about lambda expression. So we use lambda expression as called an anonymous function. So not all function requires any. For instance, if it's a one-time use function, like our uppercase now, we don't want to use uppercase anywhere else other than in this place. We could actually make use of anonymous function or lambda. And the expression is a little bit is simple, but you may not be able to like understand it quickly. So it goes like lambda. So lambda x. So this x is our value, then colon is our return value. So this x is what is taken here. This is the x, and the return value is this. So we say x dot upper. So lambda is like the name, like this def uppercase. X is the name here. Colon is the return keyword, and x dot to upper is name dot to upper. So similarly, I can actually move this here and put it here, and we should get something similar. Those is some of us. I'm going to convert it to a list. I'm going to use the map function. I'm going to use the lambda, and rather than upper, I'm going to the map. And make sure that we're within the map function. So the yellow one is for the list, the pinkish one is for, or the purplish one is for the map. I'm not going to do comma names. So remember, once we're using the map and the when we're using map function, we're not actually modifying the lists in real time. We're having a copy of the list. So I'm going to print out lower ones. As you can see, everything is now in lowercase. So initially, our names start with uppercase. By using this first one, right, we can see that everything is in uppercase. And by using the lambda expression, like I said, the lambda is like, we want to start an anonymous function. The x is our parameter in the function, and this colon is our return statement. X dot lower is similar to x name dot upper is the manipulation we want to do. Right. So let's take more example on the lambda expression. So we're leaving map for the meantime. So let us take more example on it. So we say I want to get For instance, I have a list of of numbers. I can say numbers equals to, let me just do 1 to 10. Not much. I have number 1 to 10. I could say even numbers equals to, remember, if you don't want to use the normal function, you can use a lambda. So you could say lambda, that would be lambda, which is our function. So x is the number we're taking in, right? X is the number we're taking in. So x is like when we loop over. So each of these value is x. So rather than calling it x, let me just call it number. Right. So the colon is what we want to return. So what do we want to return? We want to return maybe I want to multiply by 2 times 2. So if I multiply everything by 2, those that are not even is going to be even. Right. Remember, this is just for normal lambda expression. Right. So this is what the function does. So I'm just returning the number times 2. Or let me just call it. So I'm going to do even with number times 2. So because this is our method. As you can see, this is a function. So we have a def number times 2. It takes in a number and it also returns n. If the return keyword is not here now, it's going to tell me that it is incomplete. Expected the colon. Right. So and if I return number, I'm not doing anything. So this lambda expression, this is when it's used. So it's just that I have dev number, return any, but it's hiding the number times 2. But if I go here, as you can see, it's similar, other than this one has a particular type and knows the return type. However, for this lambda, we know that our type is going to be a number, and we're doing number times 2 because this is we're going to work with this. So if we want to filter it, so this is our lambda expression. This is our function. Like say map. So remember, the map is just a function. It takes in a function. So we want to change our list. Want to modify our list, comma names. So we have a number sign the number. So it takes in. So for each, so the way it works is just to it's like saying for numbers in numbers. So this is for numbers in numbers, right? But for number in numbers, I'm going to let's just call this one temporary equals to number times 2. So this is our temp number times 2. And we can actually update our number. So maybe have a new list called maybe number times 2 manual. So this is the manual method. So this is the manual method. So once we create a new list, right? So then I'll say maybe dot append, which is this. So remember, so this is what our map does. It's just shorter than this anyway. So as you can see, this is same thing as us writing it in one line. You can see it is shorter. So the map actually manipulates these particular numbers and it returns a new list. So and this is the function it's going to use to manipulate. It's going to use this function, which is a lambda function or a anonymous function. It's going to take each number and it's going to return the number. So this is going to loop over. So the map does looping over. It returns, and the difference is going to look at this lambda. So what does this want to? Okay, it takes in the number, which is this, which is this number here, and it's going to multiply by 2. So it's going to multiply by 2, and we're going to return the results in a list. So this is just the manual way of writing. So when I started with Python, this makes more sense to me than this, right? Well, as you get used to it. Okay, so I'm just going to delete it. I know this is going to be confusing, like I said. But once you can understand these three parts, you've done 70% of Python. So now let's go to the next one. We know. Let me just visit. So let's see this. Just comment it out. So the next one is going to be filter. So filter is very similar to one. Once you can wrap your head around map, map is just to modify the list. Filter is just to remove the, maybe I want to remove the names that are not packaged now. I can use a filter. And we're also going to make use of an lambda expression or anonymous function. So you see, maybe I want to filter names that doesn't start with O. O, let's put it O names equals to, see, filter. So I'm going to start with the filter expression. Then it takes in a function. So we can use the lambda function. I can take in the name. Remember, the colon is for the return. What I want to return. Then I could say names colon. So return where the names. We want to slice now. So I want to slice the first index dot lower. I'm going to use lower. Now explain why. I'm going to do equals to. So what does do equals to? So I want it to equals to because I've changed it to lowercase, comma, names. So let's talk about it because let's say I have another name in my list called so let's see. Now let's go over this filter function. And similarly, you have to convert it to a list. Well, let's convert it. So this lambda is what is doing the magic. We're just passing the names. Remember? So, and the lambda function reads. So we start with the lambda expression. We take in each name. So we start with the name. We're taking each name. So we're taking each name. So this name, we slice the first part of the name. So for instance, the first we take in Ola for the first loop. So I want to slice Ola square brackets 1, sorry, square bracket 0. So this is going to give me O. Remember, I want to get the first name of this Ola. So we loop over using this filter. We extract the index of 0 for each name. Then we convert it to lowercase. So for instance, so the reason why I'm converting to lowercase is it's I have O here and they are not in uniform case. Remember, Python is case sensitive. So if you write O here and I write O here and I do not change everything to lowercase and I'm doing my comparison, it's going to fail. It's not going to fail technically, but it's just going to return Oli. It's not going to return Ola and Olu. So that's why I have to convert it to lowercase. Because you may get this, this is one of the catcher like a lot of beginners fail when it comes to like string manipulation and the likes. They don't really know that they need to convert their cases. So, then we have sorry, what am I saying? And after we converted it to lowercase, then we can actually execute it. We can convert it to a list. We're going to convert it to a list. Okay. You can see we filter, we remove Tunde. Let's say I just want everything that is not O. I will just put when it doesn't equals to O. So I'm going to return everything that. So remember, this sign is not equals to. So that's just the difference. And in that sense, I'm going to have Tunde only. Right. So remember, the filter is just two things. Once you can wrap your head around this lambda expression, but you don't necessarily need to use lambda expression, but you are more likely to do it in a code base. So for instance, you can use a function, dev, let's say, um, filter, name. Oops. So I'm gonna take in a function. So it's gonna take in a string, which is the name, and we're going to call it string. So we're going to return, this is going to return a Boolean expression. So the filter takes in a Boolean expression actually. So we're going to return the name that we're passing. We're going to slice it with the index 0. We're going to convert it to lowercase, right? We're going to slice it, convert it to lowercase. If equals to zero, then we can pass it here instead of all this long garbage. Pass it filter minus. So I'm going to call the function. Right. We're going to talk about function more in depth. You can see it. I'm going to have my own names, just like how I have it before. I have everything. So I remember my only is still in lowercase. La is also in uppercase, we leave in uppercase. So my actual list is not modified, but my filter condition works with either case. This is going to be about list. Now the third one is going to be list comprehension. Now this is what you're going to see 90% of the code base, and I like this. But I found this filter and map way easier than list comprehension. Or you may find maybe I'm not really smart enough. So now I'm going to do the same thing. So the list compression actually takes in, is actually a very interesting take, right? So in the sense that we started with a list and those results. So we starting with a list. Start with a list. Now this list takes in two different parts. Now the first part is our return value. It's three different parts. We take in the list itself, and we take in our filter condition. Let's start with the return value. So what do you want to return? You want to return the name. So we'll do for name in names. It's similar to, so now, and we can have two. So for name in name, now we're returning our name. And I can actually return name dot upper. So this is this comprehension. And if I print out my results, I'm going to see everything in uppercase, similar to what we did initially. So this is actually replace our map function. So you can see Ola, Olu, Tunde, Oli. So this is our return function. So this is what we're returning. I only use a comma because of so that you can see that there are just three parts. Then I have my list or my loop. Let me just call it loop. My for loop. So the for loop. So for name in names, this is the looping. Return this one. So this is our return keyword. Then the last condition is the filter. So I could say if name equals to, but if name colon o colon o colon 0 dot lower equals to o. So this is going to return everything in uppercase now. So as you can see, we filter out Tunde. So remember, this is the for loop that we use. This is our condition, just like, but the condition is using a if statement rather than using a function. And we don't use a function in list comprehension. The list comprehension, to me, at first, it doesn't even look readable. It took me some while to actually understand what's going on. So just spend your time with it. So this is, as you can see, we've done map and filter. We've transformed. So map is for transformation of the list, and filter is for removing certain elements from the list. So we've done map and filter in list comprehension at one go without writing additional function or without writing lambda expression. Remember, this is our looping. So we use for names to loop. See, we're doing traditional loop. If blah 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 name or 0 dot lowercase equals to the same thing as 0 o, this is our filter condition. Then we're going to return name dot to upper. So we're going to return the name dot to upper or name dot to lower, or maybe we can return something else, but this is our return value. And there's no return keyword over here. So this is list comprehension in nutshell. And you can use list comprehension for multiple things. For instance, maybe we have a list. Let's say we have a list of even number. I'm not going to go this one. Let's say we have a list of number, and once we return the even number times 2, we can actually do that in one go with the help of list comprehension. So I'm just going to call these numbers. Let's see, 1, 2. Let's say I want to just call it results. Okay, results. So remember, we start from, so we loop first. In fact, I prefer the looping first. So for name, for number in number. So this is the condition. So we want to return number times 2. So we want to multiply everything times 2. Then what's our filter condition? We want to ensure that we're only targeting maybe odd number. I would say if numbers. Remember, we use the modulus to check for if a number is even or not. Modulus 2 is not equal to 0. So this, if number modulus 2 doesn't equal to 0, it's going to give us odd number. This is our loop, and this is what we are returning. We're returning the number times 2, and we're filtering everything. So what we're going to see is going to be 2, 6, 10, 14, 18. So if I print out my results, that's going to be 2, 6, 10, 14, 18. This is how we use this comprehension. So I know it's a lot to take out of. In fact, these 3 parts, once you've known these parts, you can actually like say, oh, you know what, I know Python, I can teach anyone Python. This part is going to be tricky. And I told you it took me months to actually get. That was when I was starting programming language. So you just look into it again. It's really hard to wrap your head around, like from the map function to the filter to the list. So please just go about, just try to check it. Let's go back, ensure that we understand what's going on, and we can, because I want us to move fast. We're taking too much time, spending on that Saturday. So, and this is the list. So make sure we make use of list when we want to like add, we want to have dynamic, flexible data structure to add different types in one go. And we can modify it, our list using the map and the list comprehension method. And we can also filter using the list and the filter function in Python. And there are other list related manipulation, list related function we can do. For instance, we can actually append, we can actually remove, we can delete or empty a list. So this is going to be all with list for now, right? So let's try to wrap it down at this tree. Now I'm going to be moving to the next data structure. We're going to call a tuple. So a tuple, right, is a fixed list. So a tuple is a fixed list. Tuple, So it's a fixed list. So you mean that if you know that you have a value that won't change, or you can't update a value, maybe you don't need to update your value. For instance, now in navigation, your points in the I don't know how to put it, in the latitude and longitude, it doesn't change. Only unless you are moving, but your house um points, maybe you are living in London, it's not going to change. Maybe there's just going to be some 0.1111 approximation difference between Google Map and Edge, or Apple Map, but it's not going to change actually. So we're going to use a tuple for something like that. And similar to a list, you can actually do some manipulation. So let's talk about tuples. Look, see, we could say point, also known as the names, equals to, and it's denoted with a circle bracket. We say, let's use the down and mark. Okay, so this is, I can say, this is the tuple. Of, and similar to this, we can actually add other data type. Now, we don't have the luxury to actually add, so I can add, but I can count. I can count how many items is there. It's very easy. So I'm going to print this. I'm going to print this value, and hmm, like a tuple that can pick one argument. It takes a value. We'll pick one. Oh, interesting. Mm, oh, I don't know what's wrong with it. The count function return the occurrence of values, um, occurrence of a value. Ah, let's find out to get. Let's find out to manipulate the topic. So we could. Oh my own thing. Sorry, we could have used the length function rather than count. Sorry about that. So we have three items using the length function. I don't know why what the importance of the count is. I rarely use tuple. Majority of what I use is mainly list, because this is flexible and it gives me 90% of what I need. So we talk about under data structure. So we can also unpack a tuple. So we could say first name, comma, names. But I said that we must have equal value. So we have three values. We have two. So in that scenario, or in that case, we need to unpack it into, we need to pack the main one into names. So I'm going to run this. I'm going to run names, and I'm also going to print out myself. I'm going to print out first name. Yes, run it. So I have Sunday first because Sunday is my first day. So similar thing that can happen. Similar thing that happen between a list when you are packing and unpacking. And we can also look over a tuple using the for loop. So let's look over, let me just delete this part. Let us look over our tuple. So I could say for name in names. So names, our tuple is an iterable. So I could say print name. So you can print our name. So I'm going to print our name sequentially. This can see Tunde John Mark, Tunde John Mark. Similarly, we can also use this comprehension with our tuple. Right. So, and in order to achieve that, we can do, maybe I say, maybe I want to filter. Can I do, what can I do, what can I do with this? Okay. Okay, I want to filter anyone that doesn't have N in their name. So I could say N names, because let me use English comparison. So start with a list, right? Then I don't know what do we want to return. We want to return the name. We're going to do for names, for name in names, right? So I'm going to return them. So let us print out this one step at a time. And names. So this is a list. So we have, so we're returning our name. So now the keyword is we want to search for N. Yeah, so we have everything. We're returning our N names. So now, if this is where the old condition goes into place, if name, so now we want to ensure, we want to see if we can get N from this particular name. So how do we do that in Python? Let's start. So we could use the find. So I'm going to find N. So I'm going to find N. So I'm going to convert it to lowercase first. Remember, we may have different case, but lower. Let's find N. So is now this find returns an integer. So it wants to ensure that it's greater than, sorry, is greater than or equals to 1. So if name dot lower, so this is going to convert everything to lower. So I'm going to have something like this. Then want to look for N, want to ensure that they have N. And so just to recap on these names, so we could have, if I print out name dot find N. So let's see what this is going to bring out. Let's use some other stuff. So, interesting. Then I think it returned the index instead. Okay, it returns the index. Okay, return the lowest index in S. Okay, so that makes sense now. So it return the index rather than the occurrence. How do I get the occurrence? Yes. So now, if is not equals to -1, so -1 means it doesn't exist there. We're going to filter the N names or names that contain N. So this find actually returns the index and it returns -1 on failure. So if it doesn't equal to -1, it means that that name has N in it. But I remember we're converting to lowercase. So I'm going to run it now. So we should only see Tunde and John. So this, as you can see, we have Tunde and John. So similar thing actually works in, once you can understand list comprehension properly, you're going to understand this one really easy. Like tuple is just something that you can actually add and update a tuple. Other than that, the same list comprehension. And if you say, oh, how can we convert it to tuple? It's very easy. We just call the tuple function and we'll pass in the n names. And I'm going to print out this. We're going to see it in a round bracket. As you can see, we have it back in a tuple. Right. So initially it was a list square bracket. Now it's a tuple, which is this round bracket, and with filter. So that is going to be it. I mean, like I said, majority of the time you can actually use the list comprehension for anything I can, as long as you can use a for loop for it, right? You can use list comprehension to convert it to list and either filter it or maybe change it to lowercase or the likes. But it's the condition that's actually like you need to understand what I especially if you want to filter. How do you go about understanding your condition? I also forget, like I don't remember what the find does, right? But I just have to like quickly check through it. So you can't know all the function in Python because there are a lot to take in. However, you can actually have an idea or have a feel of how it's going to work. Okay, I've used this find method before. It returns -1 on failure. I want to return anything that doesn't equal to -1, which is everything that has n in it. So that's gonna be it with tuple. So now, so this is tuple in action. So we're going to do the next one, which is going to be dictionary. So now, what's the dictionary? I'm going to delete this tuple. And this I forget. The filter function, as in this, also work with tuple. So anything that is iterable. So our tuple is actually iterable, right? So it's going to do the same thing. So we can actually do something similar to this. So in case we don't want to use so let me even use the filter. So the condition is this is the condition, but rather than this name, we're going to use a lambda. We're going to call name colon. So this is what we want to return. So once you return a boolean, then comma names. So this is also going to work. Just remember the list comprehension is just way easy. So this is what we're returning a boolean, and we're going to filter the name. Right. But remember, we can't do transformation. We can't change it to uppercase or lowercase. And if I run it, let me just clear my terminal. And if I run it, filter got two arguments. Let's see. Oh, line 5. Let's first now. As you can see, we have our tuple back. If I don't convert it to tuple, I'm going to be having a filter function like how we got a map function. So remember, we can print a list or we can print a tuple. So this is similar things we can also use for the map function. So if you understand lists very well, you can always move to other data structure because most data structure are actually built on top of lists. Okay, so I hope that makes a little bit of sense. Well, the next data structure we're dealing with is going to be called a set. Now, a set is a collection of items, is a collection of unique items. So, and is denoted by the curly brackets. So I could say names equals to, I could say Ola, Olu, Ola again. So, and if I print out my name, I should only see Ola and Olu. So as you can see, it's a collection of unique items. You can't have duplicates when it comes to a set. So that's just the difference between a set and a list. Now, a list, you can have duplicates. Supposing this was a list, we're going to have duplicates. But due to the fact that it's a set, we can only have unique items, right? So this is like, I'm not doing anything advanced so that you can go about it. But there are different ways we can actually, there are different questions we can actually solve with a set. There's problem that has to do with duplicates. Right. So, but this is not advanced data structure class. This is for testing. But let's get it. We can only have unique item when we're dealing with a set. That's the difference. Same thing, we can actually do list comprehension with a set. So this comprehension works as long as you can use a for loop. So I can loop over the names. So for names, as long as you can loop over, remember, you can always use list comprehension, or as long as is a collection of iterable, you can always use it. So if I print out name, right, I'm going to have Ola and only, despite having two Ola. So I have, sorry, because it has removed this duplicate. So we're starting from Olu. So can I call you, so you are going to start from Olu, then Ola. Then if I have Olu again, so I'm still going to have two. But it is case sensitive, remember that. So this is not going to count. So as you can see, this doesn't count. And oh yeah, this I forget again. It is not ordered. As you can see, initially we had Olu, but now we have Ola first. We have Olu's next. So list is not ordered, right? So you can't order a list, just like how you can order um just like how you can order an array. Also, I can array a list, but you can't order a set. So set is scattered. Okay, so this is list. So this is a set. So this is how you use the set. Similarly, this compression work, filter work. I don't want us to spend too much time on this. Okay, so the next one is a dictionary. So to use dictionary to store value plus. So a dictionary is used for storing key value place. And I could say user was to. So this is a dictionary. And the syntax is very similar to, apart from we have a key. So the key is name and the value is this. So this is a dictionary. As you can see, we have a dict and our key is a string. So our key can also be something else, right? But as you can see, our key here is a string. So this is a string. And it can also be double quotation. Don't get me wrong. Uh, but this is our key. So this is the key. And if I want to access my user, so I could say user dots. As you can see, I can get my keys. So we're going to talk about dictionary in detail now, just like how we talk about um list in detail. So because this dictionary is kind of like is more advanced than the lists. So the user has two different key value sets. So one is name, one is age. So I could print out user square brackets. As you can see, it's telling me, it has given me, I can now print out the name or the age. So I'm going to print out the age. You can see I have the square bracket age. So this is going to print out the age for me. And my age is 40. Similarly, I can change it to name. And I'm going to have Ola. Yeah. So this is my name and my age. Now, so this I would also use the for loop. I would say for um maybe name just call detail. So I'm going to add it in user and also use the pass so that I can show you what we have in detail. So we have detail as string. So if I print out detail, so what I'm going to have, I'm going to have the key. So the key is name and age. So how can we do that? We can actually get both the user, the key and the value. So you can use the enumerate function. So we have a tuple of int and string. Sorry, this is going to give us um what do I say? This is not going to give us the key value here. Um what was the function was collection. Um hmm, it's just not the function. I remember this function, yes. Um, sorry, I remember now. User dot items. Yeah, this is going to give us a tuple of string and any. Remember, so this is going to, I'm going to just call it key from our value. So this is how we get our key value here in one. I'm going to print out the key. I'm going to use the F string this time around to print out the key is this key from our value is this value. So this is what we need. As you can see, the key is name. So this is our key, which is name. The value is Ola. The second one, the key is age, and the value is 40, just like how we have it set. So we can also loop over the keys only. So this is one way we can loop. So another way we can loop again is for, so you could say for key user print key, right? And then do this similar thing. So say f string key colon key comma value it is one of the user square bracket key. So this should give us our value correctly. So you can see we see have the same. I've commented this out, so we still have the same thing, just like how we have it over here. This is another way. So this is the manual method. This is where you want to get it all at once in one go. And it's used for storing user detail. It's also used for storing there are different. I don't want to make this very complex, but there are different questions that is so difficult that you could actually make use of dictionary to solve. This is not a data structure and algorithm class, but it's just for you to know that you can actually store your key value here. Yeah. And like I said, majority of the time you're going to be using lists, especially as an automation tester, you're going to be using lists majority of the time. You won't use dictionary unless it's special case. And looking for example when I'm going to use a dictionary in automation. I can't think unless it's an interview setting, but I can't think of. Well, that's how it works. And there are different functions with a dictionary. For instance, we could actually append to the dictionary. We could do user dot. So we could get the key. So which key we want to get? We can get the name. But rather than using the square brackets that we did initially, yeah, that we did here, we can actually do get. So if I print this one and I run it, let me just clear everything. So I have Ola because Ola is my name. So it's very similar to the square bracket, but because of the slicing of the array is also square bracket. So a lot of people tend to use the square bracket. Even I myself I find myself using this square bracket a lot when I'm working with Python compared to using this manual method. So this one is when I'm using Java. This one I start doing dot get, dot set, and the likes. So you could also do dots. Um, you could actually get all the keys or um all the values. So let's say, remember this one actually gives us, if we look over user or we do user dot keys, we get only the keys, right? To get only the value, we can actually do for value in values, value in user dot values, open and close brackets, print value. So this is going to print out Ola and 40. You can see we printed out Ola and 40. So this is how we do our. I can also do this comprehension on the key or the value. Like I said, once you can loop over, you can actually use this comprehension. So if I use this comprehension on this generally, I'm always going to get my key back. So that's one way to convert to a list directly. So I can convert this to a list by using this comprehension, or and convert it to maybe a tuple or anyway. But this is the key concept of. So you can actually get the value. You can get using the dot get method. Yeah, but I can't really think of what you're going to use it for as your automation first. I'm just teaching so that you can know it and it's applicable to other programming language. Um, so you can actually clear. So the clear is going to delete everything. You can copy it. We can actually update. So this is going to take uh lists. Let's say I also update my age now. Let's say I'm going to be 41 this year, so I'm going to change my age. 41. I think whenever I print out user, I think I should say 41. Oh, is not. Oh, got to. Interesting. Let's see if I'm doing it right. What am I doing wrong? Minutes. So we're going to use the update keyword. Okay, so if we don't use that one, I don't know. Those two use this square bracket equals to 41. So this is one way I know of. I do, as you can see, I am 41 years. I don't know why. Okay, okay. Now I guess okay. This update actually takes in a dictionary. So I can see my age is 30 and my name is normal or again. You have changed my name. I don't change your name. What do I do? My name is Olu. If I print out user, I should see Olu and that. So this is the update method. So it's just update the whole dictionary itself. And the using the square brackets of this is actually want to update a particular value. Pretty much. So and the other one you can use, so as classificator, what you use is pop. So this pop is actually to remove a specific key. So let's say I want to remove name. I want to remove my age. Let's say I want my age to be confidential. Right. So I'm not going to print it out. You can see I only have my name as Ola, unlike here where I have my name and my age. I have my name. Because I have pop age I've removed. So pop means to remove age. So this is dictionary in action in Python. So let's talk about functions now. The function are when we want to do a particular, or rather, let me put it this way. Anytime we do the main function, this is the function. So it is used when we want to do a particular thing. So we want to achieve a result. And there are two types of function. Too many types. There are two types of functions. So the first one is that's the one that it returns a value. And the second one is it doesn't return a value. So anything. So this value can be a string, it can be a integer. This is what we currently use as our map, our filter, and the likes. For a second, I thought I was dead. Okay. Now, okay, so let's just start with it. So um we talk about anonymous function, which is the lambda expression in Python. Now we use def to start a function, which is function definition. So we start with function definition. Then let's see what we say greet user. So taking a column. So this doesn't take anything. If it takes something, it's called a parameter. If it doesn't take, it doesn't have any parameter. I'm going to say print. Hello. Okay, I'm going to say greet. I'm going to call this greet user. So as you can see, it returns none. Doesn't return anything. And let's see it returns. It's going to return 8. So this is 1. So if I print this now, I'm going to say that you're going to say hello, hola, right? Because I'm calling my function. So this is how we do function. So as you can see, it's very easy. Function is when we want to do a specified thing in Python or in any programming language. That's the function. I want to do something specific. And in this function, I want to do it to me. I want to do it to myself. So I say print hello, hola. Right, so this is the print function in action. And make user. So now we could also make this our greet user dynamic. Maybe we don't want hola. Maybe I want to greet maybe I want to greet Olu, I want to greet somebody else. I could actually pass my name as a parameter and give it a type. So the type is not necessary, but I give it a type. So I'm going to say, I'm going to use the F string and change this to, you know, and if I call this function, oh, I need to also put my parameter here. So I'm going to say, I want to greet Olu this time around. So as you can see, I have tweeted Olu. So how it works is, sorry about that. How it works is this name parameter, we're calling it here. So let me use a debugger so that you understand. So I put a breakpoint here by just clicking on the right line 7. This is our debugger, and you can also use here. So I could actually debug. I can just come here and run debugger. So I could use the Python debugger. Right. So I could also do this Python file. Right. This currently active Python file. So this is currently running. So as you can see, I put it in here. So I'm going to step into. So as you can see, we're passing Olu as the parameter, which is the name. This is step over. I'm going to step into. So meaning I'm on this function. As you can see, now Olu is replacing our name. It's going to print. That's why it's going to print out hello Olu. So I step over, and if I so as you can see, it returns none. The variable of the Python is. Oh my God. No, it's not visible properly. So I'm not going to keep stepping over. As you can see, it's printed hello Olu. So that's the end. So you can see hello Olu. No, you get hope you understand what's going on there. So the other thing is this switch user. as old, and I can change it to Peter. And if I run it, oh, I'm already doing already. So I can see we have hello Peter because our Peter is the parameter and it is changing. So, so this is it. So let's talk about the one that returns to value. If we see, solid, and we always use the same name. So the difference is just the return keyword. So we say, what can I call it? So it's just, I want to say, I'm not going to generate password. So we don't take any value, then we can return maybe not supposed to, going to be using a random value. And we'll just import state time. I can see it now. Okay. So this is going to be password. So I'm just trying to use a random password now. Can see password is equal to generate password. Then I can print out my password. Um, sorry, I'm just using the extra this time around. I'm going to put this in a curly bracket. In curly brackets. Now you can see this is my password. I have today's date. I have the time. And so you can say, oh, this is a strong password because I'm going to, and it's unique. So if I run it next time again, so I have 806. So as you can see, and just little bit of letter can actually make your password stronger. And though it is predictable, right? Because this is the algorithm. Last password 00 then UTC.data. So UTC is today's date, the time itself, right? We are currently in the 11 seconds, 0.33320. So this is just a simple function. So the main point is I use the return keyword to actually return a string, and this string is now in the generate password. So, and I can store the results in a variable called password, and I can print out my password. So that is just it. So I'm using the data. So we're going to talk about import later on because we're going to use it. It's like when we get to classes, we're going to talk about it. So I'm just going to remove from that. So this is how we return a value when it comes to, so it's one of you. This is how we return value in the function. So we just use the return keyword. That's just the difference. So we use the return keyword when it comes to Python, and it takes in a different parameter. Now, my person, my writing function, sorry, dev, we call it print names, right? I will say this is going to be first name, last last name, Let's also print out this name individually. Hit print first name. uh, I say full name. I can say, oh, and I'm printing first. Let me say generate full name. The F string on my printings. Return F string of first name space last name. And if I print out my generate full name, print what's this fake full name equals to generate full name allow comma ID. So as you can see, it has the type of any. Has the type of any. I can actually make it a string so that we know what we actually pass with string. And once I pass it in, it's going to tell my first name should be a string. If not, it's going to throw an error. Okay, so I'm going to return this and I'm going to print out my full name. So you can see I have allowed ID just like how I have it on my profile. And so this is generate full name. So what if majority of the time we don't need to pass in, maybe I don't have a last name. Maybe because of, I don't know, I don't have a last name anymore. I decide to remove my last name. So we can use the optional parameter in Python in order to achieve that, right? So if we want that, if we want to do optional parameter, or also equals to, maybe I want to use like maybe I'm creating my family tree. So I don't need to pass ID anymore. I can just pass in Ola. As you can see, it has my last name stored already. So once I pass in full name, even if I don't pass in ID, so just to recap, in case I did not pass I don't pass it as equals to, and I just remove this part, and I don't pass it, it's going to throw an error. But because of the optional parameter, right, that's why I can decide not to pass in my surname. Maybe everyone is being an ID now. So I could say, oh, you know what, I can pass in your name and use Olaide as your last name, right? So, and this is very important when you don't want to always like change a particular value. You don't want a value can be static, though that doesn't mean that my surname cannot be Adeo. My surname can always be Ade. I can always modify it. But if I know that majority of people, maybe out of 9 people, so out of 10 people, 9 of them are using Olaide, and just one is using Ade, right? I could pass Olaide as the default parameter and pass Ade later on. Or maybe someone playing well so this is going to be the rest of the member. I don't need to pass in. I don't need to pass in or like the continuously. Then it's going to everyone's going to be well ID or and similar thing can work when we're trying to construct maybe full name or full first name. Maybe some people is I did this, I did that. So we can actually use something like that. Maybe someone just something to like now Ola. So it's the prefix is now Ola. So things have changed again. You can actually use um, you can use parameter for that. So you can use optional parameter for that. So and we can also have flexible options. And okay, I think I've not talked about this. So we can always use other things apart from a string, open order. So I can say build profile, pass in the name. So this name is going to be a string, right? And I could have a star. So this is called the star alone is called ARGS. It's called argument or args. So it helps to collect extra positional argument as a tuple. So remember this star. I say we're packing a list, but this time I'm going to store it as a tuple. And when we have a double star, it's called 𝐂𝐓𝐇, which is to collect extra argument into a dictionary. So this is for dictionary, and this is a star is a tuple. So I'm going to talk about star, double star later on. So I will say extra information. I'm going to use a double star this time because I want to build user profile, just like our profile. So I'm packing everything into a tuple, into a dictionary format. I will say profile equals to name is name. Remember, we're passing our name as a string. And I will say profile dot update extra info. And I can return profile. So what this is going to do is initially I can say user equals to build profile. Let's go by. So this name is going to be this name. So the name is Alice, and we're starting our profile. So once to update our profile, right? We're passing this the dictionary. So this anytime you see if it's a single star with a tuple, if you are using double asterisk or it's called the 𝐂𝐎𝐍𝐍𝐄𝐂𝐓 or I don't know. I don't know. This is double star for it's mapped as double star. Then if you have and just normal star, and this resolves to a tuple, and this resolves to a tuple. So this is it. So if I run this one now, if I run my user, if I try to print, let me try to print the user. So I have Alice. Right. Now let's say I pass in age as what are they? 30. Or I'm using colon. I'm meant to use equals to. Which is age equals to 30. So once I do this, my age, at least age is not going to be 30. And like that, I can keep adding more values. I will see location is London. That. And we can keep adding. So we can keep adding infinity. And the tuple, sorry, and the args or the work similarly as the um X KW args. I don't know how to pronounce it. So that's this is function in a nutshell. So I'm going to see more function and more of list as we go on with automation. So that's going to be our core focus as we go forward. And like I said, we're not restricted to, you can actually pass in a number. Maybe I will also pass in, down to pass in age, int, we're going to pass in 30, right? I'm going to toss to age, age. So age. So this is our age. This is our enterprise. So even if I don't pass location as London, I'm always going to have Alice is 30 years as her age. And if I pass other information, which is for instance location or address, etc., I'm going to have it in my supposed to have it in my results. That's going to be it for now. I know that this function and the map is a little bit difficult, but we're going to see more. I'm going to try to bring more of example of this comprehension, right? More functions later. So we're still going to continue functions on Friday, but this is going to be it for tonight. So I'm going to stop sharing. So do we have any question? Does anyone have any question, please? Or do you all understand what's going on? Or you're all lost?
I'm lost, but I'll watch the video again.
Where do you get lost from? Or where did I lost you?
In fact,
I know, like I said,
I think Python is dramatic, honestly. It's not an easy way.
It's easy at first, at least. I think the beginning session was faster.
Shall I stop recording now?
Yes, please stop recording. Thank you.